Hey guys, Mr. G here, along with my trusty editor,
Hey kids.
taking another look at comparison of fractions. I hope by this lesson we've taken all those parts of knowledge and we've compared them to have a whole understanding of fractions and their value. Get it? Parts, wholes. We're talking about fractions and we're comparing them.
Yes, they get it. Let's get on with the lesson.
Okay, let's just do it then. We're going to continue to compare those fractions, but we're going to focus on, primarily in that you do, more about equivalence. Equivalence is like when things are equal or when they're the same. That's why, cue the text feature, please. In equivalence, there is the word equal. Well, I guess that's not completely true, but it's kind of like saying, if we have a Mr. G and another Mr. G, they're both equivalent. They're both equal. You guys get it?
Mr. G, you're starting to do that thing where you don't make much sense.
Well, I'm going to be honest, editor. The way you said that didn't make much sense either.
Let's just teach them, please.
All right, fine. All right, editor. Let's put the AI to good use. Let these kids know what equivalent or equivalency in the area of math means.
The term equivalent in math refers to two values, numbers, or quantities which are the same. The equivalence of two such quantities is denoted by a bar over an equal sign. It also implies a logical equivalence between two values or set of quantities.
Why did you say that in slow motion? All right, so this is going a little overboard, okay? Equivalent means they are the same. When we're talking about fractions, we can actually have different parts and sizes that actually make up the same value or the same quantity.
Mr. G, maybe you should just show them. Usually that works best. After all, as you always say, everyone learns differently.
I guess you're right. Secondly, I think we might need to update your voice. Not making a whole lot of sense.
Well, you don't either when you blab on and on.
That's fair. Let's just show them and give them a couple examples. And then we can take some look at those models again.
Sounds good.
All right, guys, let's take this for instance. I got a full sheet of paper that I am going to partition, aka fold, into two parts, which will make, cue the text feature, 1/2. All right, so I've just made 1/2 by partitioning this whole, here's your whole, by partitioning it into two parts. That would be our denominator. So I have my two parts, but in this case, when I'm talking about a half, which I'm going to be showing equivalence and comparing it in just a sec, I have this 1/2. I'm only talking about one part of those two parts that make that whole. What's crazy about fractions is that not only can they look a little bit different with their numerators and denominators and their parts that make the whole, but actually we can find a lot of fractions that are equivalent, or in fact the same or the same value as 1/2. Much like 1 is equal to 1 and 1 Mr. G is equivalent to 1 Mr. G. Especially if I got cloned and the whole remained the same. The whole Mr. G remained the same. Very important that the whole is always the same. I have this half. As we know by now, 1 over 2, a half, is indeed a fraction. But what's crazy is we can have equivalent fractions to this half and many other fractions, even when the parts of the whole change. Let's make this half into more parts. I'm going to take this half. It's a half because we had 2 parts to make the whole. This is still a whole, only talking about half. And we partition it again into 2 equal parts. So, text feature please. 1/2 could be equal to, after I fold this in half, I broke this half into 2 more equal parts. When I do that, the parts that made the whole remain the same. This is still a whole piece of paper, but we're only trying to find the equivalence of that 1/2. When I did that, take a look to what happened to the whole. I took the half, the 1 part of 2 parts to make the whole, and look what happened. I made the whole into 1, 2, 3, 4 equal parts, but we're only trying to find something that is the same to 1/2. What we did by partitioning that half, which had a whole, obviously, the 2 parts that made the whole, when I partitioned the half into 2 parts, we actually made 1, 2, 3, 4 fourths. So, cue the text feature once more. 1/2 can actually be equal to 1, 2 fourths. When the whole stays the same, the paper didn't change, but we are only trying to find equivalent fractions, which we know are less than a whole. We found even when we take a fraction and we break it into more parts, we can actually find some equivalence. Again, as long as those wholes are always the same. 1/2 is also equivalent to 2 fourths. Let's get a little bit crazier. Let's say I took this 1/2 or these 2 fourths because they're the same, and I again not only broke it into 2 parts, but I broke it into 4 parts. If I partitioned it into 4 parts, that was kind of tough. This whole is hard to partition. Let's see what happened when I took that half and I continued to partition it into more and more parts. I took that half and I then partitioned it into 4 parts. What happened was, because we're talking about the same whole, it also partitioned that whole into more and more parts. So when I broke that half into 4 equal parts that were smaller this is smaller than the half. It actually, because wholes need to be the same, it partitioned our whole into 1, 2, 3, 4, 5, 6, 7, 8. It made our whole into 8 equal parts, or eighths. So, actually, we find that 1, 2, 3, 4 eighths is also equivalent to 1 half. Cue the text feature or the text animation again, please, editor. 1 half is also equal or equivalent to 4 eighths. The parts can get smaller, but they can still make up the same value. You guys get it now?
No, Mr. G, this is really confusing stuff. Let's just focus on this for today's lesson.
That's a great idea, editor. Let's do that. All right, editor. Let the kids know what they'll need for materials today, please.
Yet again, you'll just need a piece of paper and a pencil. Make sure it's sharp. Sharp pencil makes a sharp mind.
All right, guys. With the suggestion of the editor, here's today's learning target. Using numbers and models, gotta love those models, I can determine fractions that are equivalent to 1 half, 1 over 2. One of 2 equal parts that make a whole. Finding equivalent fractions, things smaller than a whole, of course, that are equal to 1 half. Looking at more and more parts. All right, guys, so let's do it. Using that idea today to explore further equivalence, specifically taking a look at other fractions that are equivalent to 1 half. Let's start with using some models. I have here, once again, my trusty magnetic fractions. Well, we're comparing 1 half, so let's start there. As always, with a fraction, gotta start with that whole, okay? Gotta have that whole to start with every fraction. That's what's gonna start us off with that denominator, parts to make that whole. We know in 1 half, it is 2 parts, 1, 2, that make that whole. But in the case of 1 half, we're only talking about 1 parts of 2 that make that whole. We're only talking about 1 part. 1 half, modeled, good to go. To keep track of our findings, let's focus on seeing equivalence of 1 half when we're looking at making those wholes into much smaller parts, taking those halves, because halves are parts of a whole, into much smaller parts, much like I did using that piece of paper. So we're going to take a look at first thirds all the way to tenths. Let's see if there's any equivalence when we're working on or with thirds. We know when we're looking at thirds, 3 equal parts make that whole. Let's do it. 1, 2, 3. 3 parts make that whole. But we're not trying to find equivalence to a whole. We're trying to find equivalence to that half. What is the same thing as 1 half? Let's see if we can do that. Well, 1 half was not equivalent to 1, 2, 3 thirds. it was not equivalent to 1, 2, 2/3, is it going to be equivalent to 1/3? No. Interesting. 1/2 is never equivalent to any thirds. Thirds, not equivalent. Now, let's do some exploring with fourths. 4 parts that will make that whole. So, gotta start off with making that whole. We know 4 parts will make that whole. But we're trying to find equivalence between 1/2 and fourths, or halves and fourths. 2 parts that make the whole can also be equivalent to 4 parts of the whole. Let's find out. Well, we're not talking about a whole. We're not talking about 4/4. Doesn't appear that 3/4 is equal to 1/2, but 2/4 is. Interesting. Let's take a look at now fifths. Let's see if any parts of fifths can be equivalent to that 1/2. Again, finding equivalent fractions. What is equivalent when we're looking at different parts and different parts that make that whole? Unfortunately, didn't have the magnet strip to help me out with this one, but I did use my knowledge of fractions. First, I started with that whole. We know fractions always start with the whole, that denominator. I partitioned this whole into 1, 2, 3, 4, 5 equal parts. Of course, the best I could. I'm not a computer like the editor. So 5 equal parts. Clearly, 5/5 is not going to cut it. It is not equivalent to that 1/2. Let's take a look at 4/5. Equivalent? Nope. What about 3/5? Nope. 3/5 seems to be greater than 1/2. What about 2/5? Nope. It looks like 2/5 is less than 1/2 when, as always, we're comparing wholes that are the same. That's what fractions are. Equivalent parts of or that make that whole. Fifths can be equivalent to 1/2. Let's take a look at sixths. 6 equal parts that make that whole. 6 in our denominator. Where do I gotta start? Gotta always start with that whole. I know that 6/6 will make a whole. Let's make that whole first. 6/6 make that whole, but we're trying to find if there is any equivalence between 1/2, 1 part of 2/2, 2 smaller parts of those sixths. 6/6 not going to cut it. 5/6, nope, it's greater than. 4/6, nope, it's greater than. But, as you can see, 3/6 is indeed equivalent, the same, to 1/2. Sixths can be equivalent to halves. Let's take a look now at those sevenths. 7 parts that make that whole. Are there any parts of 7 parts to make the whole that is equivalent to 1/2? So, looking at those sevenths. Again, Did not have any magnet strips to help me out. Used my knowledge of fractions. I made that whole. I then partitioned it into 1, 2, 3, 4, 5, 6, 7 equal parts to make that whole. Talking about sevenths, and that's 7 equal parts to make that whole. We are comparing it to, we're trying to find equivalent fractions to 1/2. Let's do some exploring. 7/7, not equivalent. What about 1, 2, 3, 4, 5, 6/7? Not equivalent. What about 5/7? Nope, not equivalent. What about 4/7? Can you tell? Nope. 4/7 is definitely greater than 1/2. What about 3/7? Definitely not. 3/7 is definitely less than 1/2. Sevenths cannot be equivalent to 1/2. Let's take a look at even smaller parts. We're getting smaller and smaller with our parts to make the whole. Even though our denominators are getting larger, parts are getting smaller. Let's take a look at eighths. Is there any number of eighths or any parts of 8 parts that make the whole that is equivalent to 1/8? First off, gotta start with that whole. I know 8/8, oh boy, will make a whole. 8/8 will make a whole. There it is. 8/8. We're not talking about a whole. We're talking about 1/2. One of 2 parts that make that whole. 7/8? Nope. 7/8 is greater than 1/2. 6/8? Nope. Greater than 1/2. 5/8? Nope. Still greater than 1/2. But 4/8 is indeed equivalent, the same. Different parts to make the whole, different parts of, still the same, equivalent. Looking at even smaller parts that make the whole, even smaller parts. Taking a look at ninths. Once again, did not have my fancy dancy magnet strips. Had to make that whole first. Fractions always start with the whole. I partitioned it into 9 equal parts. Taking a look if ninths, any parts of 9 that make the whole will be equivalent, the same as 1/2. 9/9, obviously a whole. We're not talking about a whole, not equivalent. 8/9, nope. 8/9, definitely greater than 1/2. 7/9, nope. Definitely greater than 1/2. 6/9, nope. Definitely greater than 1/2. 5/9. Look at this. You can barely tell that 5/9 is just a smidge greater than 1/2. So we get to 4/9, definitely less than 1/2. Ninths cannot be equivalent to 1/2. All right, guys, looking at the smallest parts that make that whole today. Tenths, 10 parts that make that whole. Are there any number of parts, any number of tenths that is equivalent to 1/2. Didn't have my trusty magnetic strips again. This one was tough to partition. I made this hole and I partitioned it into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not talking about a whole. We're trying to find equivalent parts to 1/2. Boom. 9/10 greater than 1/2. 8/10 nope, greater than 1/2. 7/10 nope, greater than 1/2. 6/10 but 5/10. 5/10 is indeed equivalent to 1/2. Wow, that was a lot of exploring. We did a lot of partitioning. We did a lot of modeling. Taking a look at our model, we found, looking at all those small parts all the way to tenths, that equivalent to 1/2 is 2/4. Equivalent to 1/2 is 3/6. Equivalent to 1/2 is 4/8. And equivalent to 1/2 is 5/10. Using those models. But what about those numbers? What about those parts of that whole and the parts that make that whole? Those matter. Let's take a look at the numbers. Here you have all the findings from our exploration. Do you see any patterns? I wrote the numerators in there as well. So those that were equivalent have blue checks with the number of parts or parts of that make that whole. And I had red X's that did not have any equivalence to 1/2. Do you see any patterns? I notice that I have an X, then a check, an X, then a check. It seems that every other fraction, when we're looking at the parts that make the whole, are equivalent to 1/2. I also notice that the numerators that are equivalent are increasing by 1. I also can see the denominators are increasing by 2. Lastly, I notice that all my denominators are even numbers. Taking a look at those numbers was kind of challenging on the table that we created through exploration. Let's take a look at another way I think will help when looking at the patterns in these numbers. As you can see, I wrote down our findings. 1/2 is equivalent to 2/4. 1/2 is equivalent to 3/6. 1/2 is equivalent to 4/8. 1/2 is equivalent to 5/10. As I mentioned, our numerators in blue, they seem to be going up by 1 part. They're having 1 part more every single time we have a fraction that is equivalent to 1/2. let's take a look at our denominators, are parts of the whole. We knew we were talking about the same whole. Taking a look, it seems as though these numbers are also going up by a number. They're going up by 2. I also notice that all of our denominators are even. All the parts that make the whole are even numbers. Spoiler alert, that's because odd numbers can never have a half, as you saw with our model. There's always a little bit more or a little bit less than that 1/2 when we were working with odd parts that made that whole. Things are about to get really, really crazy for the end of this I do. We are now going to take our first step into taking a look at those operations and how math can make equivalent fractions with any fraction. So let's take a look. Buckle up that seatbelt. Going back to the beginning of this lesson, when we were talking about that 1/2, and we were partitioning that 1/2 into smaller and smaller parts, that the parts got smaller, there were more parts, but we knew there could still be equivalence. What happened to the numbers when we were making those parts smaller? We were making those equal parts smaller. We were actually multiplying and dividing. Let me try to show you with those numbers. We know for a fact, we saw it with the model, we saw it many different ways, that 1/2 is indeed equivalent, the same as 2/4. Not only do they look different, but the numbers are different, but they are equivalent. That is because when we are making parts of the whole, parts that make the whole, smaller, equal parts, we are multiplying. And they were multiplied by 2. Both parts, the part that makes the part of the whole and the part that makes the whole, were multiplying by 2. When we took a look at 1/2 and its equivalence to 3/6, we were actually also making the parts smaller. We were multiplying those parts by 3, making them smaller, 3 times as smaller, but we're still having the equivalent value. When we found 1/2 was equivalent to 4/8, we were making those parts smaller, those equal parts smaller, we were multiplying, making them smaller by 4 times. 1 times 4 is 4. 2 times 4 is 8. When we found 1/2 is equivalent to 5/10, the parts were smaller, but they were equivalent. We were multiplying, making those parts smaller by 5 times. parts getting smaller, having the same value. What's also crazy, and we didn't necessarily show it this way, is that if it's equivalent to 1/2, they're the same both ways. So, if we started with the smaller parts, they'd also still be equivalent to that 1/2. But as we actually made those parts smaller, as we actually made those parts larger, we were actually dividing equally. We were dividing by the number of parts. We were dividing by 5. 5/10 is equivalent to 1/2, but we are actually dividing by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. When we found that 4/8 was equivalent to 1/2, we were actually dividing by 4. We were dividing those parts by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. When we found 3/6 is equivalent to 1/2, we were actually dividing by the number of parts. We were dividing by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Lastly, when we found that 2/4 was equivalent to 1/2, we were also dividing by 2, those number of parts, dividing by 2. 2 divided by 2 is 1 part. 4 divided by 2 was 2 parts. The numbers were smaller, the parts were smaller, but they were the same. They were equivalent. Guys, we can find equivalent fractions, any fraction. We can find the equivalence of any fraction using math, using calculations, by making these parts larger and smaller, by multiplying and dividing. We can find equivalent fractions for any fraction. We will continue to take baby steps to use calculation to find those equivalent fractions in the last couple of lessons of this unit. No sweat if it doesn't make sense to you right in this moment. Everyone learns differently at a different pace. This was a lot. All right, guys, because that I do was really tough, to say the least. That we do, gonzo. But that doesn't get you out of that you do. Still got to show me all that learning you've been doing. And that you do, you will continue comparing fractions, whether they are greater than, less than, or now equal to. Expect to see some comparisons on your you do that are equivalent fractions. Be sure to use that length model to help you. Or, if the numbers make sense, start multiplying and dividing.